Hi, in this video we are going to talk about chapter 6, which is workplace design. There are several factors that needs to be considered in designing a good workplace, which are the following. First is illumination, second is noise, third is temperature, the fourth is ventilation, the fifth is vibration, the sixth is radiation, and lastly is shift work and working hours. My task in this video is to discuss or tackle about the first four factors, which is once again illumination, noise, temperature, and ventilation. As we go along in this video, we will going to discuss and understand as to why those factors will matter in designing a good workplace environment. Key points for work environment design. First, provide both general and task lighting, avoid glare. Control noise at the source. Next is control heat stress with radiation shielding and ventilation. Fourth is provide both overall air movement and local ventilation for hot areas. Next is dampen tool, handles and seats to reduce vibration exposure. And lastly, use rapid forward rotating shifts if shifting or shift work can't be avoided.
Let's now talk on about the first factor of work environment design, which is illumination. What is illumination? Illumination is a light that is captured by the human eye and processed into an image by the brain. The basic theory of illumination applies to a point source of light such as a candle of a given luminous intensity, measured in candela CD. If we are going to talk about illumination, this will relate to one specific part of our body, which is our eyes. Let's have a quick preview about human eye.
The important part of the human eye. Cornea. Cornea is the front part of the eye that is covered by transparent spherical membrane called cornea. Iris. Just behind the cornea is a dark colored muscle diaphragm which has a small circular opening in the middle. Pupil. Pupil is the small circular opening of the iris. The pupil appears black because no light is reflected from it. The pupil will determine how much light is let through the eye by adjusting the size of the pupil. Eye lens. The eye lens is a convex lens made of transparent jelly. The eye lens is hard at the middle and gradually becomes soft towards the outer edge. The eye lens is held in position by ciliary muscles. The ciliary muscles help in changing curvature and focal length of the eye lens. Retina. Retina mao ni ang pinaka sensitive na part sa eye. So retina is the inner part surface of the eye that is called retina. It is small, transparent membrane which is light sensitive, and it is equivalent to the screen of the camera. The light-sensitive receptors of the retina are called rods and cones. When light falls on these receptors, they send electrical signals to the brain through the optic nerve. The space between the retina and eye lens is filled with other fluid called vitreous humor. Blind spot. It is a spot at which the optic nerves enters the eye and is insensitive to light, hence the name blind spot.
Light emanates spherically in all directions from the source, with one CD sources emitting 12.57 lumens LM as determined from the surface area of a sphere, 4pr2. The amount of light striking a surface, or a section of the sphere, is termed illumination or illuminance and is measured in foot candles Fc. Some of that light is absorbed and some of it is reflected for translucent materials. Some is also transmitted, which allows humans to see that object and provides a perception of brightness. The amount reflected is termed luminance and is measured in foot Lambert's FL. It is determined by the reflective properties of the surface, known as reflectance. Reflectance is a unitless proportion and ranges from 0 to 100%. High-quality white paper has a reflectance of about 90%, newsprint and concrete around 55%, cardboard 30%, and matte black paint 5%.
Visibility. The clarity with which the human sees something is usually referred to as visibility. The three critical factors of visibility are visual angle, contrast, and most important is illuminance. Visual angle is the angle subtended at the eye by the target, and contrast is the difference in luminance between a visual target and its background. Other less important factors for visibility are exposure time, target motion, age, known location, and training, which will not be included here. Visibility will always matter depending sa location, sa tao or sa edad sa tao. Let's say for example, mas edad-edara na siya. So, may tendency nga he or she cannot see the environment clearly because of her or his age. Nasa time nga walay problema atong mata, we can see atong vision is 20/20, but it's something to do about the environment. Let's say for example, when I was in Baguio, walay problema akong ang pananaw nako, but I cannot see clearly the environment or in sa highway. It's because baga kayo ang fog. So it will matter sa kana ang angle pod, like for example sa kanang mga sakyanan, mga driver, dili kayo sila makaklaro sa gawas, especially kanang mga sakyanan for kanang sa mga bangko nga magmaba, kasi term ng mga sakyanan nga mag transfer og money, dili kayo na sila makaklaro from inside to outside. It's because limited ang ilahang kanang mga lungag pa. But in this illustration, it will tell us nga ang distance or ang visibility magdepende sa imuhang distance. Like for example, if layo ka sa light source, then of course dili kayo ka makaklaro because ang imuhang distance dili na maabot sa range sa light. But if duol ka sa light source, then of course you can see things clearly. Or illuminance. Illuminance is the total luminous flux incident on a surface per unit area. It is a measure of how much the incident light illuminates to the surface. Wavelength weighted on or by the luminosity function to correlate with human brightness perception. Now, I'll show you a short video presentation about what's the difference between luminance and illuminance.
We will learn about illuminance and luminance. Illuminance is the quantity of light or luminous flux falling on a unit area of a surface. The unit of illuminance is lumen per meter square, or lux. Here are a few examples which can help us understand the illuminance values. Summer at noon under a clear sky. In the open under a heavily overcast sky. Artificial light, office. Full moon on a clear night. Now let us understand luminance. Luminance of a light-emitting object or surface is the luminous intensity emitted per unit of apparent area of that surface in a specific direction. The unit is candela per square meter. Here are a few examples which can help us understand the luminance values. Luminance of the sun. Filament of a clear incandescent lamp. Fluorescent lamp. Road surface under artificial lighting. Now let us understand the relation between illuminance and luminance. In the case of a light-reflecting surface, the luminous intensity that the surface emits is usually not known, but very often the illuminance on the surface is. Illuminance is independent of the type of surface. It doesn't matter if it's a wall, floor, desk, or tabletop, or anything else. It only depends on the amount of light falling on that surface. For perfectly diffusing surfaces, a relationship exists between the illuminance on the surface reflectance, and the luminance of the surface. Reflectance refers to the fraction of incident light that is reflected from a surface.
In this illustration, it will show us the recommended illumination levels depending on the environment. This is actually being used by the interior design or interior designer. So we're not going to tackle the further details about this since this is actually like a detailed information, and I cannot provide the detailed information about this. So what I understand is that for us to be able to select the right range of illuminance is that we have to identify what kind of activity nga i-perform for that particular place, and also we need to consider kung ang kanang mga tao for that particular place because illuminance will also matter, or age will also matter depending sa kanang tao for that particular environment. So kung kanang edad-edara na ang tao, mga tao sa naa nga environment, there is a tendency nga mas sensitive sila sa illuminance, or ang ilang visual is sensitive sa illuminance. So that's why we have to identify the activity nga need i-perform for that particular place, and also we need to consider the age of the people on that particular place. Light sources and distribution. After determining the illumination requirements for the area under study, analysts should select appropriate artificial light source. If we say artificial light source, these are incandescent lamp or incandescent bulb, fluorescent, mercury bulb, and etc. Two important parameters related to artificial lighting are efficiency and color rendering. Efficiency is particularly important since it is related to cost, while efficient light source reduces energy consumption. Color rendering relates to the closeness with which the perceived colors of the object being observed match to the perceived colors of the same object when illuminated by the standard light or standard light sources. So as I have mentioned earlier, this illustration or this table will show us the artificial light sources, which are incandescent, fluorescent, mercury, metal halide, high pressure sodium, low pressure sodium. In this type of artificial light sources, if you notice, high pressure sodium, low pressure sodium are very efficient, because for high pressure sodium, this artificial light source will last 3 to 6 years, and for low pressure sodium will last 4 to 5 years, and samot na ang kuan mercury, which will last 9 to 12 years. So very efficient siya in terms of kanang lifespan. However, in terms of color rendering, this is very poor, or it has a poor color rendering. Let's say for example, low pressure sodium. Mao ni siyang kasagaran nga gigamit sa mga highways. And if you notice, if magpatungod ka ani nga light, mura kag tao nga patay nga nagbarog, which is luspad kayo katan-aon. It's because the color rendering is very poor. And for incandescent and fluorescent, this is actually the most commonly used nga itong gigamit sa mga balay, sa mga offices.
Luminaires or light fixtures are for general lighting, are classified in accordance with the percentage of total light output emitted above and below the horizontal. These are classified into three, which are, first, direct lighting, second, is indirect lighting, and the third, is direct-indirect lighting. Indirect lighting illuminates the ceiling, which in turn reflects light downward. Thus, The ceiling should be the brightest surface in the room with reflectances above 80%. The other areas of the room should reflect lower and lower percentages of the light as one moves downward from the ceiling until the floor is reached, which should reflect no more than 20 to 40% of the light, to avoid glare. To avoid excessive luminance, the luminaires should be evenly distributed across the ceiling. Direct lighting de-emphasizes the ceiling surface and places more of the light on the work surfaces and the floor. Direct-indirect lighting is a combination of both. This distribution of lighting is important, as IESNA, Illuminating Engineering Society, recommends that the ratio of luminances of any adjacent areas in the visual field not exceed 3:1. The purpose of this is to avoid glare and problems in adaptation.
Glare is the excessive brightness in the field of vision. This excessive light is scattered in the cornea, eye lens, and even corrective lenses, according to Frivolods, Harpster, and Heckman, 1983, decreasing visibility so that additional time is required for the eyes to adapt from light to darker conditions. Let me show you a short video presentation on what glare is.
Glare is the negative sensation produced by luminance in the visual field that is so much greater than the luminance to which the eyes are adapted that they cause discomfort, reduced visibility, or both. Glare can take either of two forms: discomfort glare or disability glare. Disability glare results in reduced visual performance, with excessive luminance leading to a loss of visibility. Probably the most important cause is scattering of light from the glare source in the optical system of the eye, notably in the cornea, the eye chamber, and the lens, to such a degree that a uniform luminous veil is drawn over the retina. It is this veil that reduces the apparent contrasts in the visual scene to impair visibility. Discomfort glare is a sensation of discomfort or even pain caused by excessive luminance in the field of view. The physical parameters that determine the degree of discomfort are largely known. The more important parameters are the luminance of the glare source in the direction of the observer, the background luminance, the size of the glare, and the position of the source or sources relative to the viewing direction. Glare can be caused due to high-intensity light sources that are out of our field of vision. When the sun is most straight overhead, the wearing of a cap serves to produce the necessary screening. There are two types of glare in particular: direct glare and indirect glare. Direct glare is caused as a result of high luminance from a light source present in the field of view. Reflected glare results from the reflection of high brightness in a polished surface in a field of view. For instance, reflection of the sun on a mirror can cause discomfort.
Direct glare can be reduced by using more luminaires with lower intensities, using baffles or diffusers on luminaires, placing the work surface perpendicular to the light source, and increasing overall background lighting so as to decrease the contrast. Reflected glare can be reduced by using non-glossy or matte surfaces and reorienting the work surface or task, in addition to the modifications recommended for direct glare.
A special problem is a stroboscopic effect caused by the reflections from moving parts or machinery. The stroboscopic effect is a visual phenomenon caused by aliasing that occurs when continuous motion is represented by a series of short or instantaneous samples. Avoiding polished mirror-like surfaces is important here. For example, the mirror-like qualities of the glass screen on computer monitors are a problem in office areas. Repositioning the monitor or using a screen filter is helpful. Typically, most jobs will require supplementary task lighting. This can be provided in a variety of forms, depending on the nature of the task. See Figure 6.7.
Both color and texture have psychological effects on people. For example, yellow is the accepted color of butter, therefore, margarine must be made yellow to appeal to the appetite. Perhaps the most important use of color is to improve the environmental conditions of the workers by providing more visual comfort. Analysts use colors to reduce sharp contrasts, increase reflectance, highlight hazards, and call attention to features of the work environment. Sales are also affected or conditioned by colors. People recognize a company's products instantly by the pattern of colors used on packages, trademarks, letterheads, trucks, and buildings. Some research has indicated that color preferences are influenced by nationality, location, and climate. Sales of a product formerly made in one color increased when several colors suited to the differences in customer demands were supplied.
Noise. What is noise? Noise is any unwanted sound. It can cause distraction, negative emotion, interference with conversation, thinking, and other cognitive process. It can also lead to temporary or permanent hearing losses. From the analyst's point of view, noise is any unwanted sound. Sound waves originate from the vibration of some object, which can turn set up as a succession of compression and expansion waves through the transportation air. So technically, noise will always matter in working environment. Like for example, in my current setup right now, I am working from home and at the same time I am located daplin lang jud sa kalsada. So sometimes naiksakinan mo kalitog ka ng agi ngakat ka ng dahog sa tingog. Sometimes mag-take og call nga mopaghot lang ang hiro og kalit. Technically, or actually, I was nakoy experience before nga kanang mga past few weeks or past 2 or 3 months ago during the work from home setup. Nag-take og call tapos kining mag-iro nga tambay diri sa kilid sa boarding house. Nagdungan og paghot. So bisan pag naka noise reduction ako ang headset, still madungog gihapon siya pag kusog na kayo ang saba. So it will always kanang matter ang noise mo, interrupt siya sa trabaho, and mo matter pud ang quality sa trabaho kung distracted ka tungod sa noise. Sound can be defined in terms of the frequencies that determine its tone and quality, along with the amplitudes that determines its intensity. Frequencies audible to the human ear range from approximately 20 to 20,000 cycles per second, commonly called as hertz, or abbreviation or symbol is Hz, or capital H, small letter Z. Before we proceed to the further details about this topic, which is the noise, let me show you a short video presentation about human ear.
The ears collect sounds and turn them into messages for the brain to interpret. They also send information about balance to the brain. 3 sections of the ear work together to make this happen. They are the outer ear, the middle ear, and the inner ear. The outer ear is made up of the pinna and the ear canal. These parts gather sounds from the environment and funnel them into the middle ear. The middle ear takes these sounds and turns them into vibrations. Sounds that come into the middle ear hit the eardrum, causing it to move. The eustachian tube helps the eardrum to work well by keeping the air pressure balanced on both sides. When the eardrum moves, it makes 3 small bones called ossicles vibrate. The vibrations are then sent to the inner ear. The inner ear receives vibrations and changes them into messages that go to the brain. These messages are called nerve signals. The inner ear is made up of the cochlea and the vestibule, which includes the semicircular canals. The cochlea has fluid in it that moves like a wave. This happens when vibrations come in from the middle ear. The moving fluid causes hair cells to make nerve signals about sound. Semicircular canals also use moving fluid to create nerve signals that help with balance. Then, the signals from the cochlea travel along the auditory nerve. Signals from the semicircular canals go along the vestibular nerve. These 2 nerves come together and lead to the brain. There, the brain decodes the signals to get information about sound and balance.
Noise measurement. Because of the very large range of the sound intensities encountered in the normal human environment, the decibel or dB scale has been chosen. In effect, it is the logarithmic ratio of the actual sound intensity to the sound intensity at the threshold of the hearing of a young person. So in this illustration, it will show us the intensity of the noise or of the sound. So in the upper part, we can see na ang numbers niya sa iyang cycle per second is gamay lang siya, which is 70 paubos, and that's the what we call threshold, in which we can consider it as a normal sound or normal noise. However, if it's beyond the threshold, which is 80 cycle per second or 80 hertz and above, that would be considered as noise na, which is annoying, saba na sa atong sakit na sa atong. The chances of damage to the ear resulting in nerve deafness increase as the frequency approaches the 2,400 to 4,800 hertz range. So technically, kung dako kayo yung cycles per second or hertz, makakuba yun ni siya sa sa pandungog sa tao. The loss of hearing is a result of the loss of receptors in the inner ear, which then fail to transmit the sound waves further to the brain. Also, the exposure times increases, especially where higher intensities are involved. There will eventually be an impairment in hearing. Nerve deafness is due to commonly to excessive exposure to occupational noise. Now I'll show you a short video presentation about hearing loss.
Today we're going to talk about noise-induced hearing loss. Noise refers to any unwanted sounds in our environment and is one of the most prevalent hazards found on construction job sites. Although noise-induced hearing loss is almost completely preventable, roughly 10 million construction workers in the United States experience permanent hearing damage each year. By age 50, 60% of construction workers develop significant noise-induced hearing loss resulting from exposure to dangerously high levels of noise at their job. This is bad news for the average construction worker, as hearing loss is both permanent and irreversible. Let's visit the science behind how sound is generated to better understand why noise-induced hearing loss occurs. Sound is a form of energy, much like gravity or heat, and is produced by vibrating objects. Take the classic example of a tuning fork. The fork consists of a handle and two tines. When hit with a hammer, the tines begin to vibrate back and forth, pushing and then pulling the surrounding air molecules apart. This motion creates sound waves, which carry outwards and eventually dissipate. The amount of energy, or loudness, of the sound is based on the amplitude of the sound wave and is measured in decibels. Sound frequency is controlled by the distance between sound waves, which determines if the sound is audible to the human ear. So how does the human body process sound waves, and what link does that have with noise-induced hearing loss? Sound waves traveling through the air are received by the outer ear and funneled into the inner ear towards the eardrum. The eardrum behaves much like an actual drum in that it vibrates as sound waves strike it. When the eardrum vibrates, a series of small bones in the inner ear begin to move back and forth. These three bones, often referred to as the hammer, anvil, and stirrup, are the smallest bones in the human body. The movement of these bones transmits vibrations directly into the cochlea, the organ that looks like a seashell. The cochlea is a fluid-filled organ lined with microscopic hairs called stereocilia. These hairs are connected to a nerve network called the auditory nerve, which turns vibrations into electrical impulses which the brain can interpret as sound. While the tiny stereocilia hairs inside the cochlea make it capable of processing a wide range of sound waves, it also leaves people vulnerable to damage from loud noises. In fact, the most common cause of hearing loss is damaged or destroyed stereocilia hairs inside the cochlea. These hairs can be permanently destroyed by a combination of two related factors, noise intensity and noise exposure. This damage accumulates over time, leaving people unable to hear higher frequencies, distinguish words, or hear over background noises.
In general, noise is classified as either broadband noise or meaningful noise. Broadband noise is made up of frequencies covering a significant part of the sound spectrum. This type of noise can be either continuous or intermittent. Meaningful noise represents distracting information that impacts the worker's efficiency. In long-term situations, broadband noise can result in deafness. In day-to-day operations, it can result in reduced worker efficiency and ineffective communication. Noise dose is a measure of noise exposure. It can be calculated using the formula on the screen, where D is the noise dose, C is the time spent at a specified noise level, hours, and T is the time permitted as specified noise level, hours. OSHA uses the concept of noise dose, with the exposure to any sound level above 80 dBA causing the listener to incur a partial dose. Today, OSHA, or Occupational Safety and Health Administration, also requires a mandatory hearing conservation program, including exposure monitoring, audiometric testing, and training, for all employees who have occupational noise exposures equal to or exceeding TWA or time-weighted average of 85 decibels. Although noise levels below 85 decibels may not cause hearing loss, they contribute to distraction and annoyance, resulting in poor worker performance. For example, typical office noises, although not loud, can make it difficult to concentrate, resulting in low productivity in design and other creative work. Also, the effectiveness of telephone and face-to-face communications.
Generally, performance decrements are most often observed in difficult tasks that place high demands on perceptual, information processing, and short-term memory capacities. Surprisingly, noise may have no effect, or may even improve performance, on simple routine tasks. Without the noise source, the person's attention may wander due to boredom.
Management can control the noise level in 3 ways. The best, and usually the most difficult, is to reduce the noise level at its source. However, it would be very difficult to redesign such equipment as pneumatic hammers, steam forging presses, board drop hammers, and woodworking planers and joiners so that the efficiency of the equipment would be maintained while the noise level was being brought into a tolerable range. Low-frequency noise at the source is effectively controlled at the source by using rubber mounts and better alignment and maintenance of the equipment.
If noise cannot be controlled at its source, then analysts should investigate the opportunity to isolate the equipment responsible for the noise. That is, control the noise that emanates from the machine by housing all or substantial portion of the facility in an isolating enclosure. This has frequently been done in connection with power press having automatic feeds. Ambient noise, or commonly known as background noise, frequently be reduced by isolating the noise source from the remainder of the structure, thus preventing a sounding board effect. This can be done by mounting the facility on a shear-type elastomer, thus damping the telegraph of noise. This is actually applicable or mao ni akong issue karon since working from home man ko. And while taking a call, bisan unsa lang ako ang background noise na iro, na ay kanang ambulansya, na motor, na sakyanan, bisan unsa na lang ang background noise while taking calls. So it may affect the productivity, it may affect the quality of the call. On the third level of noise control is with hearing protection. Though in most cases, OSHA accepts this as only a temporary resolution. Personal protective equipment can include various types of earplugs, some of which are able to attenuate noises in all frequencies up to sound pressure levels of 110 decibels or more. Also, available earmuffs that attenuate noises to 125 decibels above 600 hertz and up to 115 decibels below this frequency. Earplug effectiveness is measured quantity by noise reduction rating, or NRR, which is marked on the packaging. So technically, I think the best example for this is when you are in the machine shop. Some of them is kanang kusog yun og tingog, like I forgot naman the exact names sa kanang mga machine nga gigamit namo sa machine shop before. And yeah, what we did is we use kaning earmuffs. So of course dili man nato ma-adjust ang sound sa kaning mga machine, dili man nato ma-mute. So what we gonna do is put or use earmuffs instead para di ta magbungol.
Most workers are exposed to excessive heat at one time or another. In many situations, artificially hot climates are created by the demands of the particular industry. Miners are subjected to hot working conditions due to the increase of temperature with depth, as well as a lack of ventilation. Textile workers are subjected to the hot, humid conditions needed for weaving cloth. Steel, coke, and aluminum workers are subject to intense radiative loads from open hearth furnaces and refractory ovens.
The heat exchanges between the body and its environment can be represented by the following heat balance equation, the one on the screen, where M is the heat gain of metabolism, C is the heat gained or lost due to convection, R represents the heat gained or lost due to radiation, E represents the heat lost through evaporation of sweat, and E represents the heat storage or loss of the body. Heat stress. According to Yaglo and Menard in 1957, the most commonly used index in industry today establishes heat exposure limits and work or rest cycles based on the wet bulb globe temperature, or WBGT, and the metabolic load. In slightly different forms, it is recommended by ACGH 1985, or the American Conference of Governmental Industrial Hygienists, NIOSH 1986, or the National Institute of Occupational Safety and Health, and lastly ASHRAE 1991, or the American Society of Heating, Refrigerating, and Air Conditioning Engineers. For outdoors with solar load, the WBGT is defined as the equation below, where NWBT refers as the natural wet bulb temperature, or the measure of evaporative cooling using a thermometer with a wet, weak, and natural air movement. GT refers as the globe temperature, or the measure of radiative load using a thermometer in 6 inches or 6 in diameter black copper sphere. dB, or dry bulb temperature, basic ambient temperature thermometer shielded from radiation. Let me show you a short video presentation about what WBGT is.
We're going to discuss wet bulb globe temperature and how we use it to determine the safest playing conditions possible. So what is wet bulb globe temperature? Wet bulb globe temperature, or WBGT for short, is a way to measure the heat stress in direct sunlight. This takes into account air temperature, humidity, wind speed, the sun angle, and solar radiation. Now this differs from heat index readings, which only take into consideration the air temperature and humidity in a shady area. Wet bulb globe temperature can be used to establish guidelines for activity modifications.
Heat stress can be reduced by implementing either engineering controls, that is, modifying the environment, or administrative controls. Modifying the environment follows directly from the heat balance equation. If the metabolic load is a significant contributor to heat storage, the workload should be reduced by the mechanization of the operation. Working more slowly will also decrease the workload, but will have the negative effect of decreasing productivity.
The most commonly used cold stress index is the wind chill index. It describes the rate of heat lost by radiation and convection as a function of an ambient temperature and wind velocity. But what is wind chill index? On the next video presentation, it will gonna show us what wind chill index is.
In winter, you'll often hear weather reports give an actual temperature and a feels like temperature, which is always much cooler than the actual temperature. What this feels like temperature is based on is something called the wind chill index. The wind chill index is based on two things: the actual temperature and the wind speed. Wind speed affects the rate of evaporation of moisture from exposed skin. Evaporation removes heat from the skin surface, which lowers body temperature. Higher wind speeds then mean more evaporation, which means more heat loss from the skin. A formula for this type of heat transfer has been devised along with a table to show this effect. The National Weather Service Wind Chill Index calculates wind speed at a height of 5 feet, uses a standard skin tissue resistance, and assumes no impact from the sun. For example, at a temperature of 0 degrees Fahrenheit and a wind speed of 20 miles per hour, the wind chill index, or feels like temperature, is minus 22 degrees. Under these conditions, frostbite on exposed skin can occur within 30 minutes. At minus 15 degrees and a wind speed of 45 miles per hour, frostbite can occur within 5 minutes. Hypothermia, a decrease in the core body temperature, can occur under much milder conditions, even when the temperature is above freezing.
If a room has people, machinery, or activities in it, the air in the room will deteriorate due to the release of odors, the release of heat, the formation of water vapor, the production of carbon dioxide, and the production of toxic vapors. Ventilation must be provided to dilute these contaminants, exhaust the stale air, and supply fresh air. To better understand the importance of ventilation, let's watch this short video clip.
Imagine spending several hundreds, if not thousands, on insulating your home to be told you have to put holes in it to let cold air in. Or imagine building a new home to new energy efficient standards, and again, the better it is, the more holes you are told to put in it. Well, this is exactly what people are being asked to do. So why? Let's explain. While we can't control the cost of fuel, we can control how much energy our buildings need. And the less energy our buildings need, the more people we lift out of fuel poverty, improve society and the environment. This common sense energy approach is what fundamentally drives increasing standards in new housing and national programs for improving our housing stock. But as we rush to seal our homes from the cold, we should remember we have to live in them too. And live in them we do like never before. In fact, we spend up to 90% of our time indoors, where the indoor air quality can be many times worse than the air outside, causing a range of problems including respiratory illnesses. So we find ourselves in a dilemma. A bit of a tug of war, if you like, between closing up our homes to seal in the heat and opening them up to let fresh air in. Ventilation is basically the mechanism by which we do it. Take bad air out and let fresh air in. So what is bad air? Well, actually, it's mostly caused by us and the stuff we do. And other than ventilation for things like fires and boilers, it can be broken down into three main groups. Moisture. That's cooking, washing, drying, and so on. The average family of 4 can produce 16 litres of moisture in a week. If the moisture is not dealt with, it condensates on cold surfaces, causing mould. which damages our home and proves an ideal environment for other nasties too. Great if you have asthma. Metabolism. That really is us. CO2 from breathing, which includes more moisture and of course odours. While odours are just unpleasant, too much CO2 for too long is not good for us, affecting concentration and causing fatigue amongst other problems. VOCs. These are quite complicated and are basically chemicals that we don't really want about. The vast majority are okay, but some are very bad, and we try not to have them in our houses in the first place, in paints and varnishes, etc. But we do have to mitigate the risk with good ventilation. Some pollutants, like moisture, are easier to spot. When we have a shower, for example. The problems it causes can also be very visible, mould, but others are less so. It's a bit like boiling a frog. Bear with me. It would react to boiling water as you would imagine. But if you sit it in cold water, then warm it up slowly, it will sit there quite happily until, well... Put it another way. Have you ever been into a teenager's bedroom? That's the indoor air quality equivalent of jumping into boiling water. The occupant, probably still asleep, seems quite happy there though. In short, we can be just terrible at recognizing poor air quality, especially when it builds up around us slowly. In the context of a simple ventilation system, your humble hole in the wall, do we really expect to get up halfway through our TV program and open it up a little, or close it before bed to control CO2? Of course not. What we tend to do is, the first time we feel cold air coming in, we shut it, and often leave it that way. And herein lies the rub. Until now, we mostly got away with it because, well, so much of the air that came into our buildings got there through leaks. But as we build more airtight homes or seal up our old ones, we rely more and more on ventilation. So when we close a vent, or switch a fan off because it's noisy, how else will the air get in? Are we slowly turning ourselves into frogs? To ignore or not integrate proper ventilation systems into our homes is simply leaving ourselves open to risks that shouldn't be acceptable. Although a hole in the wall has its limits, there are now many better alternatives. Proper, well-thought-out ventilation secures good indoor air quality and provides a comfortable and energy-efficient environment for us all to enjoy our homes.
This ends my presentation here. Good work design is very important as it provides good, safe, comfortable working conditions for the operators or for employees. Advantages of the workplace with good working conditions are the following. First, it increased production or productivity. Second, improve the safety record. Third is to reduce absenteeism, tardiness, and labor turnover. Next is raise employee morale, and lastly, improve public relations. Thank you so much for watching and have a good day. Keep safe.